Hey, pre-calculus folks. I miss you and wish we were in school. Doesn't look like we'll be back for a while. So just wanted to make a video here because we started doing matrices this week, and your calculator is really awesome at matrices. I want you to be able to do the easy stuff by hand, but there's something in Khan Academy that they don't do that makes your life really easy. So I wanted to go through how to make your calculator do the heavy lifting for you. And also, if you don't have a graphing calculator, I found a good site that I'm going to link to this video in Classroom. So you can do this step. And this is kind of to help you on one of the problems, maybe two of the problems on your quiz coming up here, either Wednesday night or Thursday. Hope you're doing great. You guys are doing a great job getting your work in. Really impressed with that. Wish we were there because you're missing out on some pretty sweet jokes that now my kids have to listen to. So I'll have to do my kids have been doing some magic tricks. I'll have to steal some of theirs and do some for you soon. Anyway, let me get into this. So I'm going to shrink myself down there. So this is a brutal problem. In Algebra 2, you would have something easier like if I had 2x plus 3y equals 8, that's just a separate problem. And then negative 4x plus 6y equals negative, 15. So let's say you had that problem and you were asked to solve. You could solve this problem. I don't think you'd have too much trouble. You could use, it's called elimination, or there's substitution. I guess linear combination is what it's called. You could do either of those ways to solve this, and you try to make this a 4x and then a negative 4x, and you add down. And you do all that stuff. And you guys have done it. You could also graph them and see where they cross. Problem with a problem like this is it's brutal because there's 3 variables, and if you've ever done one of these by hand, well, I don't even like doing them by hand, and I'm a math teacher, so that should tell you something. So I'm going to show you how you can use matrices, and this is one of the reasons matrices are cool and why we even learn them, aside from the movie The Matrix with Keanu Reeves. So if you get a problem like this, the first thing you need to do is make sure that all the x's are lined up, all the y's are lined up, all the z's are lined up, all the equal signs are lined up, and all the constants are lined up. Sometimes you'll get a sneaky problem where these will be switched around on you, and you have to know to rewrite them in order, or the whole problem doesn't work. All right, after you do that, this is called a system of equations. In order to turn this into a matrix, you basically have to get rid of all the x's and the equal signs and all the junk you don't need, and all you really want to keep are the coefficients. So if I look at this, I really have 1, 2, 3, 4 things across the top, and those are my columns. See how I have my columns going down like that? And I have my rows going across, and there's 1, 2, 3 of them. And you can kind of see a matrix here. You don't even have to look that hard. So I am going to make a matrix that is 3 by 4, and it's called an augmented matrix. Really, all it does is take out all the junk and make it a lot nicer to look at. So remember, when you name a matrix, the order you name it in matters. This is how many rows. Remember rows, this is row 1, row 2, row 3. And then this is how many columns you have. This is column 1, column 2, column 3, column 4. If you ever get mixed up, columns are like those Greek things in architecture that go up and down and hold the roof up. So columns still go up and down. Oh, I smudged it. Eeh. All right, anyway, so I'm going to write this equation without all the junk. I just want the coefficients. Like the number in front of the x is a -1. The number in front of the y is a 2. The number in front of the z is a 3. And the number off to the side of the equal sign is a -17. And then I can do it with this row. I'm just going to write the 4, the 2. There's a 1 there. Don't be tricked. Just don't say 0 because there's actually a 1. And a 3. And then the last row, there's a 1 there, a 5, a -2, and a 12. And you can kind of see why the order matters, because the thing that matrices are good about is putting things in order. It's kind of like your Excel spreadsheets or Google Sheets if you've ever used them. And I know in Khan Academy you learned how to like multiply a row by 3, or switch 2 rows, or subtract 2 rows. And those are called elementary row operations. If you do a bunch of those, you can mess with this until it gets into reduced row echelon I had to think of how to spell that, form. Or as the cool people call it, RREF. I use the term cool very loosely here. So if you can get this thing to have a 1 here, a 1 here, and a 1 here, and zeros everywhere else, it actually is like doing all the hard work to solve it. But we're going to make our calculators do the hard work. So I'm going to type this matrix in my calculator. You can do lots of cool things with your calculator. So let's see how to do that. First, if you've never seen it before, right here above the x to the -1 is the word matrix. So you hit second matrix, and I'm going to scroll over to edit if I'm going to type this matrix in. And it doesn't matter which letter you pick, but you're going to type this matrix exactly like you see it. It's a 3 by 4. You had to know that, and you have to type it in here. 3, enter, 4, enter. And it makes all these zeros. Now just type in these numbers as you see them, like -1, enter, 2, enter, 3, enter, -17. So we're just cruising down the rows. 4, enter, 2, enter, 1, enter. Just take a little extra time, because if you screw this step up, well, there's no chance you're getting it right. And, you know, you might as well try to get it right. So I do all that work. Yeah, that's pretty bright. I do all that work to try to, can you read that? Yeah, okay. To try to type it in just like that. Now here's the cool part. You can make your calculator do all the other hard work, which is row reduced echelon form. Your calculator is going to be doing like probably 30, 40 steps for you, where you multiply this one, you subtract it from here, you add it to there. Anyway, here's what it looks like. You go back into matrix, second matrix, but this time, don't go over to edit. You want to go to math, where the good stuff is. And if you scroll way down, I usually scroll backwards, you will see letter B here is RREF. And that means reduce row echelon form. If I hit that, oh crap, hold on. That's a rookie mistake. Okay, I need to quit out of here first. Oh, at least I made that mistake, so you don't have to do second quit. Okay, so you're on your normal screen. Now do second matrix math RREF, which is faster to go from the bottom. And you have to tell it what matrix to do RREF on, which is, you go back to second matrix, and matrix A is my only matrix, so I just hit enter. And if I do that, what's cool is it did all the dirty work for you. Now, I'm telling you right now, this is called an augmented matrix. Or sorry, this is your row reduced matrix. It's not your answer yet, but it's close. So I'm going to write this down on my paper. 1, 0, 0, 2. Crap, that looks terrible. Let me try that again. 1, 0, 0, 2, 0, 1, 0, 0, 0, 0, 1, -5. that has the answers in it, but don't mistake that for the answers. That's just this guy was called the Augmented Matrix, which is taking out all the junk. This is when you do row reduced echelon form, and then you need to actually reinterpret what this means. Do you remember what the first column meant before we took out all the junk? What was that? They were all x's, right? So what does this actually mean? 1x, no y's, no z's, equals 2. This line right here translates literally into x equals 2. Like the last line would mean no x's, no y's, 1z equals -5. And this middle row, no x's, 1y equals, well, 0. Sometimes they just equal 0. Oh, that brings me up to the other point. Remember I said don't be tricked. If this is a plain z, you need to put a 1 as its coefficient. What would make a 0 show up in here is if there wasn't even a z. Like if you just had an x and a y and you didn't even have a z, it would be like having 0 z's. So anyway, isn't that awesome? I mean, if you've ever done one of these by hand, that problem would have taken like, I don't know, 15 minutes of hard concentrating work, and then you'd still have to make sure you didn't make any mistakes during that 15 minutes, like missing a minus sign, you're done. So anyway, thought I'd show you that. That is how you solve a system of equations with matrices. Saves a ton of time. A couple vocab terms. First of all, goes rows by columns. It's called an augmented matrix when you take out all the junk. You have to put the junk back in later, but once it's way nicer. This is called reduced row echelon form. And if you've ever seen geese fly, they fly in an echelon pattern. That's why it's called that. This is like 3 geese flying. Geese are mean. I've taken a lot of walks lately. Man, they're mean. Anyway, some of them hissed at us. So I want to show you real quick. I'm going to attach this on here. This is the website that I think is awesome. It's Reduced Row Echelon Form Calculator online. I'll put this in a link. I typed in the exact same things. I had to type in the 3 and the 4 and then all my coefficients. And then I just hit calculate. And just like my calculator works, if you go down here, not only does it show you the solution, but I like this. It shows you all the moves you would have to do to it. Like if you did it by hand, this is what you would be doing. You would first take row 1, multiply by 4, and put it along with row 2 to kill that to a 0. And then you do this to make that a 0. And then you do all this. Man, there's a lot of craziness. Eventually, you don't care about all that stuff, but if you had to do it by hand, look at all the steps. You seriously would have had to do all these steps without messing up. And you get to here. Is that the exact same answer as before? Heck yeah, it's the exact same answer as before. So anyway, thought that would help you out. We're going to do more with your matrix, with your calculator and matrices, but anyway, if you ever want to, send a video back just to say hey, or I've had a few people sending messages. It's just nice to talk to people sometimes. I miss you guys. Keep doing the good work, and I will talk to you later.